Hello, welcome to Einstein Mechanics once again. Today we are going to solve problems on centroids of composite shapes. So this is the episode 2 on problems concerning composite shapes. So we take our time and we go through that. Let's look at example 1. So we have this plain figure of composite shapes, two or more shapes together, and we are to find the center of this shape. So first, let's adopt the table mode. What we do is, to get this, we have to get our shape. How many shapes do we have? We have 1, we have 2, and we have 3. So I can get up to 3 shapes from this composite shapes. So for each of them, I have to get the area for that, and for each I have to get the X bar and the Y bar for each. So this is the table approach: the area, the X bar, and the Y bar. You can do that nicely by getting your table done. So figure 1. So I can say this is my figure 1 and this is my figure 2. I'll call this as my figure 3. Let's look at the area for figure 1. So area 1, which is equal to, the area is 12, which is the length times the width, and that is going to give me what? 72. So the area is in centimeter square. This is in centimeter and this is also in centimeter, and that is going to give me centimeter square. A2, my A2 can also be calculated, and I'm going to get that. So let's say A2 is equal to, this is a triangle or a right angle triangle, and it is going to be half the base, which is 12, times the height. Looking at the radius of the circle, this is the same as what? 6, and that is going to be that of 6. So with this, the area is going to be what? 36 centimeter square. My figure 3, which is A3, is a semicircle, and we know the formula for area of a circle is pi r square. So this is half of a circle, that is going to be half pi r square, and that is half pi. The radius is 6, and that is squared. So with this, you are going to get your area to be 56.55 centimeter square. So you can bring them here. Area 1 has 72, area 2 has 36, and area 3 has 56.55. Now let's try to locate the X center for each of the shapes. From the shape 1, to locate the X center to its center, let's say somewhere here. This is 12, so the center for the rectangle is going to be what? 6. You are right. And for the area 2 or the figure 2, to locate the center of a right angle triangle, moving from the angle side, we are going to move 2/3 of the base. If we are coming from the 90-degree side, we are going to move 1/3 of the base. So since the axis is at the 2/3, where we have to move this part, we are going to move 2/3 of the base, and that is what? 12. Are we okay? So 3 into this, 4. 4 by this, that is going to give us 8. So we move 8, we will locate the center. Is that true? All right. So the same way, we can move 1/3 of that, and we will also get it. So 1/3 of the base, which is 12, we can get a value here as, which is 4. So moving from this side, we can move 4. Let's say 4, and the entire distance is what? 12. So moving from here is 4, meaning you have to move here 8 to be able to get to this side. Any of the approach will get you to the 8. What about the semicircle? In order to get to this place, what do? We know that when a semicircle is, if we want to locate the midpoint or the center of a semicircle from the base, let's say from the base to this side, the formula is giving us 4r on 3 pi. Is that true? 4r on 3 pi. So here we know the r to be 6, and our midpoint for just the semicircle is going to be 4 times 6 on 3 pi. Is that true? But before we can locate this center, we moved a certain distance called what? 12 before we got to here. So that is going to be plus 12. So typing all this 4 by 6 on 3 pi plus 12, you are going to get the center to be 14.55. This 12 is going to help you. Only the 4 by 6 on 3 pi is going to give you 2.55, and plus this 12 is going to be 14 point that. Let's try to locate the y distance. The y distance too here from shape 1, its vertical axis is going to be, the entire distance is 6, meaning to locate its axis or the center, that is going to give you 3. For shape 2, from the 90 degrees up to locate the center of a right angle triangle, you have to also move 1/3 of the height, and the height is 6, which is the radius of the circle, and 1/3 of 6 is going to give you what? Yes, 2. But before you move from the x-axis to the center, you covered a certain distance, 6 here. So 6 plus the half or the distance for the center, which is 2, is going to give you 8 before you locate the center of the right angle triangle. And for the semicircle, if I'm to locate the center on the y-axis, I would move the radius and I will locate it, right? And the radius is also giving us 6. So once you fill your table, now everything becomes easy. So to locate your x bar, that is going to be summation of the individual x bar multiplying the area on summation of the area. So this is going to give us our 72 by, since we are working for the x bar, plus our 36 by 8 plus the area, which is 56.55 by 14.55, everything on summation of the area, which is 72 plus 36 plus 56.55. And with that, your x distance for the composite shape is going to be 9.37 centimeters. The same thing happens to the y bar. Summation of the individual y bar by their areas over the entire summation of the area, and that is going to be 72 by 3 plus 36 by 8 plus the 6 multiplying 56.55, everything on summation of the area, 72 plus 36 plus 56.55, and your y distance is going to be 5.13 centimeters. So moving 5.13 on the y and on the x 9.37 will give you the center for the composite shape. So example 2. Let's look at how we can also solve such an example. So here we have our shapes given. Are we okay? So we call this shape 1, 2, 3. I will adopt the table approach. So I have my shape, I have the area for them, the X bar for the individual and the Y bar. How many shapes? I have 1, 2, and 3. It's very easy if you go by the table. So like this. So from the numbering, this is from 0 to 2 to 8 there. Are we okay? And the rest we can obtain it from, and the height is also giving us what? 3. So let's see, from shape 1, what is our area? The area for shape 1, we know that this is a triangle, and the area 1 is going to be half the base, that is 2, times, what do we have? The height, and that is also going to be what? 3. This is half, not 1/3. So this is half. So half, 1/5 of the base, which is 2 times the height. And when you solve this, half of 2 is 1. 1 multiplied by 3, that is 3 for you. No centimeter or meter given, so we just leave it in the number, that is 3. Our area 2 is also going to be from the numbering 2 to 6. What is the number difference? That's 6, right? All right, and the height is also giving us 3. So our 6 by our 3 and our A2 is giving us 18. For area 3, this is a semicircle, so half our pi r square. And looking at this, from here to that place is a diameter, and the diameter is giving us what? If the diameter is 3, then the radius is going to be 3 on 2, and that is going to be what? 1.5. So half of a circle, pi r square, 1.5 square, and that is going to give us 3.53 as the area. Are we okay? So we can just bring them here. This is 3, this is 18, and this is 3.53. Let's try to locate the center, the X center for them. So this is a right angle triangle again, and if I'm to locate from the angle side, that is going to be 2/3 of the base. Is that true? Yes, it is going to be 2/3 of the base. And this is the 90-degree part. This is the 90-degree part, so I'm going to locate from this place. So 2/3 of the base, that's the base is 2, and that is going to be 4/3. And when you punch 4/3, what are you getting? That is 1.33. 1.33, like this, for the center. 2/3. You can move from here, that's 1/3, and you get a value you subtract from 2. Anyway, will still work. Going for this shape 2, remember from here to here is 6. Are we okay? Is 6. So half of it will be 3. But before you move from here to the 3, you occupy another distance, which is 2. So this 2 plus this 3 is giving us a 5 over there. Is that true? All right. Now shape 3 is the same as what we did, a semicircle, and if we were to move from the base to the center, that will be 4r/3 pi. Here our r is giving us what? Half of the diameter, and is 1.5. So 4 by 1.5 on 3 pi. But before you get here, you have to move a distance all the way from 0 to 8. So that will be 8 plus 4 times 1.5 over 3 pi. And that is going to give you 14.5 Sorry, that is giving you, I'm having 8.64 for the X on shape 3. What about the Y? So for the right angle triangle, to get the Y shape or Y center, so we are trying to locate the Y part of them. So let's see. So the Y for the right angle triangle, that is shape 1, is still going to be moving from the base to locate the center. That is going to be 1/3 of that, the height, that is 3. And this is going to give you what? 1. So this is 1. When we locate this, this is 3. The height is 3, so locating the center will be half of it, and that is 1.5. The same thing happened to the semicircle. It has a diameter of 3, so half of it, the center will lie at 1.5. So once the table is done, then our S prime for the center is going to be this 3 multiplying 1 point that plus 18 multiplying 5, and we have 8.66 or 64 multiplying 3.53. Everything on the area. And with this, our S prime is going to be 5.08. The Y prime is going to be the area 3 by 1 plus 18 by 1.5 plus 3.53 by 1.5. Everything on the area. 3 plus 18 plus 3.53, and your Y bar is giving us 1.44. So with this, you are going to have your center. So the center XY is 5.08, 1.44. Very good. All right, so let's look at the last example. So we have this figure. You can pause the video and try your hand on it. So I will call this figure 1, and I'll call the rectangle as my figure 2. So this is figure 2 and this as figure 3. So the same approach, you have to get your table, my shape 1, 2, and 3. The area, the individual X bar and Y bar. You get it nicely, and once you fill the table, everything is complete. So here, the same area 1 is a semicircle, which is half pi r. Looking at this diagram, the diameter is given as what? 40. D is 40. So our r will be what? 20 from the dimensions here. So that was 20 square, and the area is going to give us 628.32. Area 2, this is length times width, 80 by 40, and that is giving me 3200. And A3 is, this is a triangle, half the base, and the base dimension is giving us 40 times the height, and it is also giving us what? 40, and that is going to give me 800. So I have 628.32. This is in centimeter square, this is in centimeter, centimeter. So 3200 and this is 800. Are we good? So let's try to locate the various x bar and y bar. This semicircle, I can locate it from the base. Look at here from the base. We know that from the base it is 4r on 3 pi. Are we good? So we have our r to be what? 20. Are we good? And this entire distance is what? 20. So 4 pi or 4r on 3 pi, that is going to give me, so 4 by 20 on 3 pi, that is giving me 8.48. 8.48. So meaning the center from this base to this center is 8.48. Meaning if I'm to refer it from this side, I will subtract this from the entire 20, and that is going to give me a distance of 11.51. Are we good? So locating the center from the y-axis here will be on the x 11.51. Do you understand that? Okay, so now we locate it for the rectangle. We know that this is 80, so definitely the center will be at somewhere 40. But before you get to this 40 from this side, there's a distance 20 from the axis, so that is going to be 60. And for this third shape, we have to locate its center. How do we also do that? So this center is, we know the height of the triangle. We also know what? The base. So locating the center from the y-axis, the center will lie somewhere on this axis. You see that we can divide this into 2 to get that. And when I divide this into 2, I'm getting 20 here, 20 over there. Are we okay? So this entire distance from 20 to this 80 is going to give me 100. Is that true? And if it is 100, to locate this distance, I can subtract this 20 from it, and that will be the distance. That's the center for that. So moving from the y-axis to this center is giving us 100 minus 20, and that is 80. Are we good? We can locate the y distance too. So the y for shape 1, that's the semicircle, is just half of the diameter, and that is going to be, the diameter is 40, so it is going to be 20. And for the rectangle too, it is 40, so its center on the y is going to be 20. What about the triangle? Before we even locate its center, we have to cover a distance of what? 40. So we have a distance of 40 to be covered, plus how to locate its center. We know that the center of a triangle can be 1/3 of the height, and the height is what? 40. So 40 plus 1/3 of 40, and that is giving me 53 point. So that is giving me 53.33, and we have that. So here, once you go through the same approach with your x bar is going to be 11.51 times 628.32 plus 60 by 3,200 plus 80 by 800, everything on 628.32 plus 3200 plus 800. Your x bar for the composite shape should be 56.87, and the same thing for the y bar is going to be That's 20 by 628.32 plus 20 by 3200 plus 53.33 by 800. Everything on the area 62832 300 plus 800, and your y bar is 25.76. Thank you for watching this episode. Look out for the next episode on polar moment of inertia. Thank you.